Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is XOR equals subtract. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. An array A is called good if it satisfies the following condition. That is for all pairs of I and j such that I is less than j in our array A, then the XOR between the numbers ai and aj is equal to the absolute value of the difference between them. We are given an array A of n integers and we have to find out the maximum size of a good subsequence of A. For input format, we have t test cases and for each test case we'll have two lines. The first line contains the integer n, that is length of our array A, and the second line will contain n spaced integers a1, a2, a3 till an. As for the output, we simply have to output the maximum size of a good subsequence of A. As for the constraints, number of test cases will go from 1 to 100. Length of our array A will also go from 1 to 100, and the values of elements in array A will go from 1 to 2 raised to 30. Let's see some sample inputs. So for the first sample input, the array has length 4 and the elements are 3, 1, 2, 1. Let's take a subsequence that is something like this. Let's take 3, 1, 1. Now, if we take 3 in binary, we can write it as 1, 1, and if we take 1, it is written as 0, 1. If we take their XOR, the value is 1, 0, and even if you subtract that, the value is again 1, 0. And if you have to compare for 1 and 1, again the subtraction is 0 and the XOR is also 0. Therefore, 3 is the longest length that we can go here. For the second sample input, we have 3 elements, but all the elements are same. So this is evident that this is the maximum length, 3 itself. Let's see how we can approach the solution. Before we move on and develop any sort of approach, let's see what are the values of bits when we do XOR. So let's say we take A and B and we do the XOR. So if the bits are 0, both A and B, the XOR value is also 0. If the bits are different, that is either 0, 1 or 1, 0, the XOR is 1 and 1. But if both the bits are same, that is 1 and 1, the value is also 0. Similarly, let's see what happens if we subtract. Again, we have A and B and we do the subtraction. Again, if both the bits are 0, 0, the subtraction is also 0. If we have 1 and 0, again, we will subtract nothing from 1. The answer is again 1. If we subtract both ones, it will be 0. But what happens in the case when we are trying to subtract 1 from 0? In this case, we have to do a borrow, right? And this is the difficult situation that we do not want to deal with, or in fact, we can't deal with because the values will not be same. So what we need to do is, we need to find numbers in such a way that all the bits at ith position in the first element that we are looking at has to be greater than and equal to the same bit in the second element. So if we look at this, it can be 0, 0, it can be 1, 1, or it can be 1, 0, but it should not be 0, 1. In that case, our XOR value, that is A XOR B, will not be equal to A minus B. So when we say that the bit has to be greater than or equal to the other bit, in a way we are talking about submask, right? So what we can do is, we can sort our array in a non-descending order, and then we can check for elements. We can check for element A and I and J. Since these are in non-descending order, AJ will be greater. So we can simply check if we do a bitwise AND of it and we get the same number as AI, we can say that it is a submask of AJ. We can do this for all the elements in n square and find out which is the longest subsequence, and that length will be our solution. Let's see how we can implement this in C++. So for each test case, we call the function solve and take the input of our array. Then we sort this array, and then in an n square loop, we go through each of the elements. For each greater element, we check all the smaller elements and check whether it is a submask. For that, we simply take the bitwise and if it is equal to the bigger number, sorry, if it is equal to the smaller number, we know that it's a submask. If that is the case, we update our DP value. And at the end, whatever is the maximum length, we print that. And as you can see, I've got an AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n, our array, sort it in increasing order, then we initialize our DP with 0 values, then we loop over each number and check if the smaller numbers are submask. If that is the case, we update our DP value and at the end we print the maximum. And with this, we'll get the maximum length of subsequence that is a good array. And as you can see, I have AC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.